Hold on. All right. Okay, now. Okay, welcome to Dynamics class. We are in week 13 already. Okay, the final 2 weeks of our class. So for today's class, what we are going to do is we're going to start and discuss on previous final exam questions. So I have picked a few final exam questions for us to discuss. So this is the first question that we will discuss today. This is question number 4, April 2011. Okay, now, okay, I'm going to read the question. We're going to read the question together. Okay, I hope by now you have copied this question into your notebook. Okay, each of the double pulley, so there is a double pulley, pulley A and pulley B. So each of the double pulley, if you notice, there's pulley A and there's pulley B. Okay, has a centroidal mass of moment of inertia. So dia dah ada I kat sini. Dia bagi tahu the I value is 0.375 kilogram meter square. Okay, with an outer radius. So kat sini dia ada bagi outer radius and inner radius. Okay, so there's an outer radius and there's also an inner radius. Okay, the outer radius is 225 mm. The inner radius is 150 mm. Okay, same again for pulley A. The value of the inner and the value of the outer radius. Okay, now neglecting friction of bearing. Okay, now question number 1. Determine the velocity of block C. So it wants the velocity of block C at time equals to 5 seconds. 5 seconds after the system is released from rest. Okay, now after the system is released from rest. Okay, the next question, solve the tension in the cord. So here we have tension of the cord. Okay, let's label this cord TD because there's a label D there. So we have tension of the cord. Okay, it behaves in tension, so it's pulling. It behaves is pulling. As you can see, it is pulling the pulley. Okay, so this is we need to find the tension of the cord. Okay, this one we have to find the velocity of block C. Now to answer the first question, the velocity of block C, based on this, what method do you think we need to use to solve this question? Previously, I have taught you there are two methods that we can use. What you need to do is look at the variables given. Which method is the most appropriate method or principle to use? Which principle do you want to use? Can you please tell me? Hmm. Why are you so quiet? Teguh Ashraf, which principle do you want to use? Hello?
Hello there.
Which principle you want to use? Remember, there are two types of principle I taught you for rigid body. Which principle you want to use to solve the velocity? They ask you to find the velocity. Find the velocity. They give you the time. Now, which principle you want to use? Hmm? Sheikh Ahmad, which principle you want to use?
Uh, Impulse and momentum.
Yes, why you didn't answer me if I asked? If you know the answer, you should answer. Whether you get it right or wrong is okay, but you need to answer and try, okay? So the method is principle of impulse and momentum. Why? Why?
Have time.
Yes, because if you have velocity, you have the time, then the suitable principle for you to use is impulse and momentum. Okay, good. Okay, so for this question, they ask you to determine the velocity of block C after the system release from rest. So since we have decided we're going to use principle of impulse and momentum, what we need to do is we need to write the equation of principle of impulse momentum for pulley B and for pulley A. Okay, since there are two pulleys, you need to write two. One you need to do for pulley, one for pulley B, one for pulley A, and one for pulley B. Okay, let's do for pulley B first because it's the diagram is much more simpler lah. Okay, so for pulley B, as you remember, you have to draw three diagrams, right? So there will be three circles. One, two, and three. Now, the first circle is what? System momentum 1. Do you remember that? The first circle is system momentum 1. And what is the second circle?
Angular impulse.
Yes, system angular impulse. The second is system
System momentum 2.
itu third. System external impulse 1 ke 2 and then system angular momentum 2. Okay, good. Next, let's make the diagram correct. So there's another circle inside here. Okay. Okay, please draw nicely. Don't follow my diagram. Okay. So for the first diagram, system momentum 1, what we have is due to the rotation. So let's assume the block is moving downwards. If the block is moving downwards, the rotation of the block will be like this, anti-clockwise. So dia macam ni. Okay. And for the rotation, it's going to be I omega. But of course, this one will be I omega for pulley B. But for 1, this one will be I omega for pulley B, but for system momentum 2. And then for the system external impulse, what external forces you have involved? So since it's connected to the tension cord TD, so there's a tension cord TD here lah. Okay. And then of course biasalah kita akan write by, bx and whatever lah, due to weight ke apa. Kat sini doesn't involve lah. Okay. Just write yang ni lah pun boleh. Okay. Just to simplify things. Okay. Alright. Now. Okay. So now, because we're going to do for pulley B, what you need to do is what we're going to do is we're going to take moments about B to write. Moments about B. Okay, there should be a dot in the center here. Okay, now. Okay. Jangan lupa because this is due to time, so the tension of the cord TD kita multiply dengan time. Kita jangan lupa tak tu. Okay, now let's take moments about B. So we take moments about B. What do you think system momentum 1 will be? System momentum 1 will be 0. Why 0? Can anyone answer me why 0? Cuba read the question. Here, the clue. The
From
system
rest.
is, yes, released from rest. So system momentum 1 will be 0. Okay, again, plus, okay, plus T, D, tension of cord TD, multiply by T, and you must not forget you need to multiply by R, equals to I omega B, okay, for system momentum 2. Okay, now. Okay, so if you notice, if you simplify this, it will be T dt. Okay, now what is R? Okay, now if you look at system external impulse 1 ke 2, the R for the that is connected to the tension cord, is it the inner radius or the outer radius?
Inner.
Inner, yes. If it says it is the inner radius, the R will be 0.15. I changed the unit from 150 millimeter to unit meters, so it's 0.15 equals to I. In the question, I is given already. What is I? 0. What is I? 0.375. Okay. And what is omega B? Omega B we need to find. Okay, so this is something we need to find. How are we going to find omega B? Remember this formula? V equals to what?
R omega.
R omega. So we're going to find omega B using this formula V equals to R omega. Okay, now, okay, let's put on hold this first and write down equation for pulley A first, and then we simplify things later. Okay, let's do for pulley A first, pulley A. Later we will come back, okay? Later we will come back here. We do for pulley A first. Now, for pulley A. Okay, again, for pulley A, what do we need to do? We need to draw how many diagrams? 3. Am I right? Okay, we need to draw 3 diagrams. Okay, so first diagram. Okay. Okay, this is for pulley A. Include the second diagram. Okay. But then there is a tension of the cord here and equal to the third diagram. Allah, my diagram. Okay. Alright, now. Again, you have to write the same thing. Jangan malas. System momentum 1 plus system external impulse 1 ke 2 equals to system momentum 2. Okay? Alright, now. Okay, again, we know there is for pulley A, there is a rotation. And block C ni, this is block C, we have MB. Okay, remember this is for B is for block C. Okay, and then we have I omega. Omega is omega A for system momentum 1. Again, here we have TD multiplied by T. And then we have here due to the weight is W, T, we have to multiply by the radius R. Okay, and then again it rotates like that. So for system momentum 2, we have I omega A for 2. And again we have for block C here, we have M V C but for 2. Okay, now let's write down the equation. So when we write the equation, what are we going to take? We are going to take moment about A. Okay, so lupa buat this dot tengah to complete the diagram. Okay, now so when we take moments about A, since again the question it is starting from rest, so for system momentum 1, it will again equals to what? 0, plus Okay, so plus when we look at the diagram, we will have W T R. Okay, minus because the direction of the tension cord is the other direction. So it will be T D T R equals to I omega A plus M V R. Okay, boleh? Now, okay, so if we write down the equation, W is mg. So what is the mass of block C? This is Wc. What is the mass of block C? In the question, did he give you? Please have a look at the question and what is the mass for block C? Let me know.
15.
Okay, 15. So 15 multiplied by 9.81 multiplied by the time, which is 5 seconds, is given. Now, for block C, this block C, it is that R, the radius. Are you going to use the inner radius or the outer radius?
Inner.
Inner. Okay, 0.15 minus TD. Okay, times T. Now, what is the R for the tension of the cord? Is it the outer radius or the inner radius?
Outer.
Outer. Okay, good. 0.225. Okay, equals to I. I is already given in the question, 0.375. Multiply by omega A, which we do not know. Okay, plus M mass, 15 kilograms, times VC times R. Now, again, the R for the block C is the inner radius. Okay, now. So if you notice, for these two, what we need to do is we need to simplify these two equations. We need to simplify this first equation and the second equation. What we need to do is we need to find omega A and omega B. Okay, now let's find omega A and omega B. Okay, again, you remember, you told me just now to find omega, you're going to use the formula V equals to R omega. So find omega A first. So omega A will be V divided by R. Okay, so for omega A, what is the V? We need to find, this is what we need to find lah. It will be VC lah. Okay, for omega A, kita ada VC. Okay, what is the R? For block C, the R will be the inner radius or the outer radius?
Inner.
Okay, 0.15. So 1 divided by 0.15 is 6.67 VC. Okay, now let's find for omega B plus. Omega B, if you notice, if you look at the diagram of omega B is connected to cord VD. So it will be again V divided by R, but it will be VD divided by R. And the R for omega B, what is it, the inner or the outer radius? Have a look at the diagram. The R. The R for omega B for TD using the inner or the outer radius?
Inner.
Inner.
Again inner. Okay, good. The inner. So the inner is again 0.15. But as you notice, the answer is in terms of VD. So we need to change this VD and make it into VC. So if you look at pulley A, again at pulley A, if you observe at pulley A, we know the formula is for pulley A, we have the block C. We also, for pulley A, we also have the tension cord D, isn't it? If you notice at pulley A, we also have the tension cord D here. So what we can do is omega, sorry, omega block. we can find VD dalam sebutan VC because VD is, and then VD for pulley A. Okay, this one is for pulley A. This one is for pulley B. So for pulley D, sorry, pulley D pula dah. Okay, for pulley A, if you notice VD is omega. The R uses the base, which is 0.225 multiplied by omega A. So basically, and then we know what is omega A. Omega A is what? This one, right? So we can just multiply 6.67 VC. Can you please multiply for me? 0.225 times 6.67?
1.5.
Okay, so you get 1.5 VC. So all you need to do is all you need to do is put it inside here. So it will be, because this is VD. So 1.5 VC divided by 0.15. So 1.5 divided by 0.15 easily 10 VC. So now what you have? You have omega A dalam sebutan VC, which is 6.67 VC. You also have omega B dalam sebutan VC, which is 10 VC. So what you do, you eliminate the unknowns. Okay, so this is a bit tricky, this part, but I'm sure you can manage lah. Okay, so let's go back here. Let's simplify this one. So what we do, we jadikan TD as the main tajuk. TDT equals to 0.375. What is our omega B? Apa tadi? What is our omega B? 10 VC, yeah? Okay. Oops. 10 VC divided by 0.15. Can you please simplify this? What do you get?
25 VC.
25 VC. Okay. This is TDT. Sebenarnya you boleh divide by time. Lupa nak bagi divide by time. So if you divide by the time, if you divide by T, what do you get? Tapi tak apa. Nanti dululah. 25 VC ya. Kita biarkan dalam sebutan dulu. Okay. Kita turun bawah dulu. Nanti kita divide by T tu. Okay. So kat sini, can you please simplify this one? 15 kali 9.81 kali 5 kali 0.15. What do you get?
$110.36.
Okay. And then tadi TDT tadi kita dah dapat tadi ke atas tadi. 25 VC. Ni kita dah dapat dah tadi. Okay, tolong simplify yang kat sini. Oh, sebelum tu kita kena gantikan ni. Omega A. Omega A tadi kita dapat apa? 6.67 VC. Okay, ni ganti. Plus 15 kali VC kali 0.15. Okay, alright. So from here you can find VC straight away. Can you please find me VC straight away? What I'll do is I'll simplify belah sini dulu. Can you please simplify this side? All this? What do you get? Dapat berapa? 4.75, betul tak? Okay, now find me what is VC. Unit must be in meter per second. What do you get for BC?
$10.64.
Okay, that is correct. And then find me TD. So tension of TD will be 25 times 10.64 divided by 5. So what is TD?
53.185. 186.
186. So 33.2 Newton. Okay, so that is the answer. Okay, that is the answer. That is the answer. So that is correct. Okay. So I think we have done a lot of questions that uses linear impulse or momentum. So if you notice, the method is the same. Okay. So this question is very simple. It looks complicated, but actually all you need to do is write the principle of impulse or momentum for pulley D, and then write another simple equation for principle of impulse and momentum for pulley A. Pulley A, there the additional block C lah that is connected to it. And then from the equation, the tricky part is you need to simplify the equation to make it easy to solve, whereby what you do is for the omega A and omega B, what you do is you try to relate it in terms of BC. So this is what you have done here. And then you put back into the equation to find the velocity of block C and the tension of the cable TD. So that's how you to do it. Right. So the more you try other final exam questions, you will find it much more simpler and straightforward. Okay, so a good practice will be very useful. Okay, all right. Next. Okay, so we have done this question. Now, have you done this question? Can you answer me? Have you done that question?
No.
Okay, why haven't done that question? Your friends mentioned that they have done that question because I have shared a recorded video of myself explaining that solution. Did you not watch that video? Yang
Watch.
jawab no tu. Watch. So why you didn't do it? Are you telling
No,
me everyone in this class did not do this question yet?
I thought do the first one only.
No. I did a recorded video of myself last time, not today, and I shared for you to watch it. Supposingly, if you have watched it, you have done this question. Understand? Okay, so it shows that the recorded video that I have given to you, it seems that some of you did not watch. If you had watched that video, you would have done this question already. You understand what I'm trying to say?
Yes.
But you did not. Okay, now I want to ask, did anybody in this group have done this question? Just answer yes or no. Yang jawab, yang saya nak yang answer yes or no. Did anybody in this group have done this question? No, nobody. Okay, never mind. I guess it's a mystery for you to try to find in. Do you want to discuss this question?
Yes.
Yes, okay. We can discuss this question, but I would have appreciated it if you had really watched my video, okay? Because it seems that some of you are not watching it. Okay, hold on. Okay. rugi because I have done a lot of videos. I shared with you multiple types of different types of question. If you're not watching it, then it's your loss lah. Okay. All right. Okay. Now, okay. So, for this question, I'm not gonna go into detail exactly. We're just gonna discuss on how to solve it. Okay. Let's read this question. So this question is year January 2012. Question number 4. Okay. Now, the double inclined plane supports two blocks. So there are two blocks. Block A is 15 kilogram. So let me write this down. Block A is 15 kilogram. And then block B is 5 kilogram. The system is released from rest in the position as shown in figure question 4a. The coefficient of friction between the block and the incline. So there is a friction already given. So the friction. So there is, oops. So the friction is given 0.30. The pulley has a mass of 4 kilograms. So even the pulley has a mass 4 kilograms. Okay, and the radius of gyration is 0.1. So dia dah bagi the radius of gyration is 0.1. Okay, now using Newton's second law, so we know Newton's second law is F equals to ma. Express the equation of the motion of the blocks and the pulley. So dia kata equation of the blocks. So what you need to do, you need to write the equation for block A. You need to write the equation for block B. And you need to write the equation for the pulley. Okay, so how are we going to do that? We're going to use the Newton's second law expression. So for each equation, if you notice, there are 6 marks. So this will be, I guess, 2 marks, 2 marks, 2 marks. Okay, so how are we going to do this? Okay, in order to solve this, what we need to do is we need to make sure we can draw the correct free body diagram first. Okay, let's draw the free body diagram first for this diagram. Okay, what do we have? First, for block A, of course, you will have the weight, am I right? And then you have the normal force. Okay, now okay, for this question, did it mention the direction of the block? Okay, for this question, it says it didn't mention the direction of the block. Okay, now if we assume block A is going to go down, the acceleration is going down, what will be the acceleration for block B? It will be going up, right? Am I right?
Yes.
Okay, right now let's assume we do know the acceleration, but if you get the acceleration negative, it means the assumption that you have assumed is the opposite direction. Itu saja. There's nothing wrong with it. Okay, let's say the acceleration is going for block is going down. So if the acceleration of the block A is going down, what will be the direction of the friction force? It will be the opposite, right?
Yes.
Do you understand?
Understand.
Yes.
Okay. All right. Again, for block B, there will be a weight going down. And again, there will be normal force. Since the acceleration of the block is going up, then there will be a friction force in the opposite direction lah. Okay. Again, because this is a cable, this is a cable, okay, which is connected to a pulley. Again, there will be a tension cord here. So let's say this is tension cord 1. And let's say this is tension cord 2 lah. Okay, tension is pulling the force. That's why the diagram is like that. Okay, now since we have done our diagrams correctly as it is, so what we need to do now is we need to write the equation lah. So how are we going to write the equation? Okay, now so for the equation, okay, so for the equation, okay, let's say kita assume summation forces F equals to MA going up is positive. So what do we have? For block A, we have T1. Am I right? What else we have in that direction? We have the friction force in that direction. What else we have? What we need to do now, we need to resolve this, right? The weight. So if you resolve the weight, what will be W? Cos or sine? Sine theta, right?
Yes.
Okay, so it will be negative W sine theta equals to, okay, now, since we assume our direction to be positive going up and our acceleration is going down, that's why you have a negative ME here. Okay, so if we simplify this again, T1, now friction is what? Mu Kn. Okay, minus mg sine is what? Sine 60 equals to negative MA. Okay, now, okay, hold on, eh? Okay, now for this question, since this is a topic, a rigid body, and there is a pulley with a mass and everything, so our A acceleration has to be in terms of alpha. So acceleration, another formula is R alpha. Okay, so our acceleration here is using R, which is the radius of the pulley, which is 0.05 times alpha. So for here, what we need to do is we need to replace our acceleration as 0.05 alpha. Okay, so what you need to do is you need to simplify this equation. Okay, but before that, wait, I haven't simplified yet. 0.3 now. What is N? Normal force. Hold on. So if the weight is resolved in the x direction, W sine theta, in the y direction, it will be W cos theta. So what is your normal force N? Let me write down here. Your normal force will equal to W cos theta, which is mg cos 60. So here your N will be mg cos 60. Okay, minus mg sine 60 equals to negative m times 0.05 alpha. Okay, now, if you simplify this, can you please simplify this now? Do you get the same answer as me? 105.363 minus 0.75 alpha. Okay, don't forget your mass is 15 kilograms for block A and your G is 9.81. So this is your first equation. Okay, because they ask you to express the QA equation for each block. So what you need to do, you need to do the same thing, the same process for block B. But when you do for block B, your answer, okay, I'm going to make this quick a bit. Your answer will be 37.269 plus 0.25 alpha. So this is your expression for block B, yeah? Okay, you can try to solve yourself and check your answers later. Okay, but the important thing is you understand how to do it. Do you understand how to do it? Can
Yeah.
you
Yes.
you can try nanti balik nanti you can try and do it again, eh? And check whether you get the same answer for me with me. Okay, next for your pulley. Okay, now let's say now um let's say your pulley is positive in that direction. So when we want to do the equation for your pulley, it will be T2 multiplied with the radius, which is 0.05, minus T1 times 0.05 equals to I alpha. Okay, now you have to calculate I. How do you calculate I? Now for this question, because it gives you your radius of gyration, the I that you need to use is mk squared. What is the mass of the pulley? Dia dah bagi kan 4 kilogram. What is the radius of gyration? Dia bagi 0.1 square. So ya ke? Sekejap. Radius of pulley is 0.05. Radius of gyration is 0.1. Oh, so K is, let me read the question. Radius of gyration is 0.1. Can you please calculate for me 0.1 times 4? 0.1 square times 4 dapat apa?
Zero point zero four.
Okay, so this one should be here. Okay, so then you will get your equation. So what you need to do is, you will get your third equation. Okay, all right. So this is T2 0.05 minus T1 0.05 equals to 0.04 alpha. So this one will be your third equation. Okay, now, okay, oops. Okay, now, so when you have these three equations, what you need to do is you need to solve it simultaneously. And what would you get? You will get alpha. So you can get the alpha value in radian per second squared. And then after that, you can answer question number 2. Find the angular acceleration. So just solve this equation using simultaneously and you can get the answer for alpha. And then for the next question, calculate the acceleration of the block. So to calculate the acceleration of the block is very simple. Acceleration is r alpha. We know the radius is 0.05. So all we need to do is multiply by alpha, the alpha that we get. And then what we can do is we can get the acceleration. So the acceleration, the answer will be in meter per second square. Okay, all right. And then for the fourth question, solve the speed for block A. So for the fourth question, it wants us to solve the speed for block A. So to solve the speed of block A, we can use the kinematic equation V equals to U plus AT. So the V is what we want to find, which because they ask you to find the speed of block A, U is 0. Acceleration is acceleration you have found it here. And they ask you to find the speed of block A after 5 seconds. So you times 5. Okay, because they ask you at time 5 seconds. So you will get the answer in meter per second. Okay, very easy Rasa boleh buat tak?
Boleh.
Okay, now if you can do that, it means that what you can do is you can solve this other third question. Okay, if you notice this third question that I'm pasting you, I'm going to copy this question. I'm just going to explain you how to do it, but we're not going to do it. Okay, just general on how to solve it. Okay. Oops. Apa tak ada besar kan? Hold on. Oops. It's too small. Okay. All right, now for this question is the same question. If you notice, the question is the same based on the free body diagram. Determine the equation of motion using Newton's second law for the block. So for the same question, okay, for the same question kejap for the same identical question, kejap where is that question? Ni apa ni? June 2000. Okay, kejap. Let me find this one. Okay, for the same question, June 2012, we have a dot merah tu. Okay, for the same question 2012, again, what you need to do is the same thing. You need to find what? You need to write the equation for motion for block. Oh, besarnya dia tu. Sekejap Again, you need to find equation for motion for, again, for block A. You have to write the equation of motion for block A. You need to write the equation for block B. And again, you need to write the equation for the pulley. Okay, the same thing. And then after you have write the equation, you need to find the acceleration. So you need to find the angular acceleration. The answer will be radian per second squared. Okay. And then determine the angular velocity. So to determine the angular velocity, you can use this formula omega sama omega naught plus alpha t. Okay, from there you can get alpha. T you can replace with 3 seconds. Okay, omega is 0. Then you can find the answer. Your answer will be in radian per second. So it's the same concept. But the difference is in this question, um, is the same. Cuma gambar dia just like je lah. You have to do the weight. You have to draw the end. Okay. Now for this question, there is a trick kat sini. Dia bagi tahu smooth plane. So kat sini tak ada friction force. Itu saja. So again, ni akan jadi tension 1. Ini akan jadi tension 2. And then ni weight, ni normal force. Okay. And the difference kat sini, dia ada radius yang berbeza. Satu outer radius, satu inner radius. So kalau yang outer radius tu 0.02, inner radius 0.01. Okay, alright. Okay, ini pun sama. Kalau you nak calculate I, you kena pakai mk squared sebab dia bagi radius of gyration. Okay, so do you think you can try to answer this question also? Boleh?
Boleh.
Senyap je?
Boleh, Doktor.
Boleh kan? I rasa you can try because you need to try. Okay? If you notice, if you try, more questions you try, the more idea you have to solve and you can solve. Okay? So if you notice, the questions are also similar saja. Cuma diagram berubah. Okay? Alright. Dekat sini dia minta angular velocity. Macam tadi dia tak minta angular velocity, dia minta lain kan? Dia minta apa tadi? Dia minta speed of block. So speed of block kita pakai formula yang V sama dengan V naught ACT. Yang ni kita pakai formula omega sama dengan omega naught plus alpha T sebab dia nak angular velocity. Macam tu lah. So the more you try more final exam questions, the more you can answer. Okay? Alright, so it will be a good practice lah. So kalau macam tu nanti again as I mentioned, what I'm going to do is for this upcoming class, kita akan try the other 2 final exam questions that we have not tried. And then after that, for this week, make sure before your before your assignment 2, make sure you look at my video. Okay, I will send you the video within this week before Friday. Okay, have a look. I will try to make the video very short, not too lengthy for you to watch. So itu saja. Okay, so any other questions? Okay, let me stop this video. So okay, I think we end our class punya session today. How to stop? Okay, stop recording. So okay. Alright, I'm gonna stop now. Okay.